Right, so the first question asks which one of the arrangements shown in figure 2 would give a 4.5 volt output across the battery pack terminals T. So the first thing is we need to try and put them in order so you can see them clearly. So you can see there's a small one here, a large one here, small terminal, large terminal, and then we've got a large terminal and a small terminal, and that means there's two positives together, so that clearly cannot work. This one we've got large, small, small, large, so we've got two negatives together, so that can't work. You got small, large, small, large, small, large, so we know it's this one because the terminals go from negative to positive, negative to positive, negative to positive, so it must be that one. Right, complete figure 3 to show how an ammeter would be connected to measure the current through the circuit. So you'd need to put an ammeter somewhere in series. So here or here would make the most sense. So remember, the ammeter always goes in series and voltmeters always go in parallel. Right, how could the potential difference of the battery be calculated from figure 4? Well, the potential difference is going to be the sum of the components in the circuit. So here we've got a variable resistor and here we've got a resistor. So when voltmeter 1 reads 3 and voltmeter 2 reads 9, the sum of it is 12 volts. So that is because it is the total potential difference. So when the two are added together, we get the total potential difference because the PD is shared. And it's shared between the resistor, which I'll say is R, and the variable resistor. Right, use figure 4 to determine the resistance of the fixed resistor R. Okay, so what we want is when the potential difference is the same, so at 6 volts, we know the resistance. So when this is 6 volts, we know that this is 6 volts. So therefore the resistance is the same. So when the PD is 6 volts for both of them, then the resistance is equal, and that represents 600 ohms. So that's because the potential difference is shared equally across both components. So the resistors have the same potential difference and they have the same resistance. So both resistors have the same potential difference and resistance is equal. Right, calculate the current through the circuit when the resistance of the variable resistor equals 200 ohms. So if we go back, you can see at 200 ohms here we have a voltage of 3 volts. So if V equals I times R, then I must be equal to V divided by R. We said that the voltage was 3 volts and the resistance was 200 ohms. When you do 3 divided by 200, you will end up with a current of 0.015 amps. The next question says a washing machine is connected to the main supply using a cable and a 3-pin plug. Name the material used in the structure of the plug. Give a reason for why each material is used. So the pin is made of brass, and a reason for that is it is strong, but it also conducts. So you don't want it to bend because it needs to be of a solid structure when it's plugged into the wall and removed from the wall. So it also needs to be very strong, but it also has to conduct electricity. The outer casing you would want to be made of plastic because you don't want this to conduct, and we call that an insulator. Right, which one of the wires inside the cable is the fuse connected to? It's always connected to the live wire, and remember the live wire is brown. The fuse is a thin wire inside a glass tube. The wire acts as a resistor. What effect does a current through a wire have on the wire? So a current going through any wire causes a heating effect. and that is because the metal ions in the lattice vibrate faster, and when this happens it causes the wires to heat up. This is due to collisions with the electrons. The power of the washing machine varies between 0.7 kilowatts and 2 kilowatts. Calculate the maximum current drawn from the mains electricity supply by the washing machine. So the maximum power is 2 kilowatts and the mains supply is at 230 volts. Remember, mains is always 230 volts, and that is AC at 50 Hertz. Remember, that's really important. Now, power is equal to voltage times current. So if we rearrange this, I is equal to P divided by V. The power is in kilowatts, so we need to change that into watts, which is 2000 watts, and we divide that by 230, and that will give us our current, which is 8.7 amps. Right, if a fault makes the metal case live, the earth wire and fuse inside the plug prevent the mains cable from overheating and causing a fire, so we need to explain why. So in here we can clearly see the earth wire, and it's connected to the metal case. Now the earth wire provides a path of lower resistance. So earth wire provides path of lower resistance. Now because it provides a path of lower resistance, the current surges as it passes from live to earth. And if you get a current surge, the current surge is going to blow the fuse. So this blows the fuse, preventing wire from overheating. And that overheating would cause the fire, so we don't want that to happen. Right, new research has shown that many people understand the hazards of using electricity. Explain what is important. People do understand the hazards of mains electricity, so you see yes why. So that is so people do not get electric shocks or electrocuted. Right, draw a ring around the correct answer to complete the sentence. When the resistance of a circuit increases, the current in the circuit decreases. Now remember that if V is equal to I times R, then R must be equal to V divided by I. So these two are inversely proportional to each other. If you increase R, you must decrease I, and so on and so forth. If you increase I, you must decrease R. So remember, they are inversely proportional. Use the correct answer from the box to complete each sentence. An electrical component which has a resistance that increases as the temperature increases is going to be a filament bulb. Okay? Remember, this is one of the assessed practicals. So as the potential differences increase through a filament bulb, the current will increase at a directly proportional rate until the wire gets hot, and you get a graph that looks something like that. And then it starts to curve, and you also need to know that the same will happen in negative value. Okay. An electric component which emits light only when a current flows through it in the forward direction. So that forward direction is talking about a diode, but this is a light emitting diode, so that is an LED. When some metals are heated, the resistance of the metal changes. The equipment for investigating how the resistance of a metal changes when it is heated is shown in the diagram. So you can clearly see here we've got a thermometer, a metal sample, a beaker, a voltmeter and an ammeter, and a Bunsen burner to heat the beaker up. So it says, describe an investigation a student could use to find how the resistance of a metal sample varies with temperature. We need to include in the answer how the student should use the equipment. We need to include the measurements that they should make, how the student should use the measurements to determine resistance, and how to make sure the results are valid. Okay, so the first thing is we need to use the Bunsen burner. So we're going to use the Bunsen burner to heat water to different temperatures. Now you need to include some kind of range here, so at selected values such as 20 to 80 degrees C. Now I've just made that up, but you need to have something suggested. And we're going to give some intervals, so with 10 degrees C intervals. Now remember, intervals is the amount it goes up each time, so you're going to have 20, 30, 40, 50, 60, 70, 80 degrees C. You're going to use the thermometer to check the temperature. And then you're going to use the voltmeter to read voltage at different temperatures. And ammeter to read the current. You then use V equals I times R, and you're going to rearrange this for R, so you're going to say R is equal to V over I. Now because you've just worked out the voltage and the current using this, you can then work out the resistance at all the different temperatures, and you're going to record in a table. And it says you need to make sure the results are valid, so you're going to repeat each test 3 times. Okay, now that's plenty of information to get you full marks, but make sure you include lots of information, more information than is required, so therefore you're guaranteeing yourself of 6 marks. And use bullet points and make it clear. Think about how you're going to answer this before you start the answer. Okay, the table shows some data for samples of 4 metals P, Q, R and S. So you got P at 4.05 and 5.67, and this is at different temperatures, so at 0 degrees C and at 100 degrees C. Which metal sample P, Q, R or S has the data shown in the graph? So clearly this is around 3.5 and it's at 100 degrees C. So we're looking at 100 degrees C, and that is roughly 3.5, so it must be Q. One of the results is an anomalous. Circle the result. Now remember, this is one that doesn't fit a pattern, so that's clearly not fitting a pattern. Suggest a reason for anomalous results. Now really these are mainly to do with error. So if you say human error, then that is likely to get you something. But being specific, you could say human error, e.g. not reading thermometer properly. So that's an example of a human error. The next question says the same equipment used in the investigation could be used as a thermometer known as a resistance thermometer. Suggest 2 disadvantages of using this equipment as a thermometer compared to a liquid in-glass thermometer. Well, one is this whole equipment is much harder to transport than just a glass rod, so it is hard to transport. Another example could be that for this, so it's obviously very difficult to set up, it will be a bit of a faff to set up, and you also need some kind of power source as well, so needs electricity and hard to set up. Okay. Right, this next question is about power generation. So it says in 2013 about 80% of Iceland's electricity was generated using hydroelectric power. Describe how hydroelectric is generated in a power station. Include the useful energy transfer. So we need to talk about how energy is being transferred. So if we have a little diagram just to show what's going on, then in a hydroelectric power station you've got all this water and there's a dam. And from the dam there will be some kind of pipe network or tube that runs down to lower ground, and the water up here has a high gravitational potential energy, and as it falls from this high gravitational potential energy it is transferred into kinetic energy, and that kinetic energy is used to drive a turbine. And as you drive the turbine, the kinetic energy is going to be turned into or transferred into electrical energy. So you've got this transfer from gravitational to kinetic and then to electrical. Now remember, in the new specification you need to talk about stores. So we start off with a store of gravitational potential energy, and then the store is decreased from gravitational potential energy and it increases the kinetic energy store. As the kinetic energy store is depleted, the electrical energy store is increasing. So we get an increase in electrical energy. So how are we going to put this into words? Well, the first thing we need to say is that the water moves from high gravitational potential energy to a lower GPE by moving from high ground to low ground. The GPE is converted or transferred to kinetic energy. The kinetic energy in water drives a turbine moving a generator. This transfers kinetic energy into electrical energy. Okay, so remember, it's these energy transfers that are taking place, but you need to be specific and write in good written communication. Right, the UK produces most of its electricity from fossil fuels. Many people in the UK leave their televisions in standby mode when not in use. It is better for the environment if people switch off their television instead of leaving them in standby. Explain why. So it's 3 marks. So the first thing is talking about standby. So in standby, the TV is still using electricity. If you are using electricity, then that is produced by burning fossil fuels. So electrical energy is produced by burning fossil fuels. So what's the problem with that? Well, if it's to do with the environment, then we need to talk about the production of carbon dioxide. So burning fossil fuels produces CO2. And what's the issue with CO2? Producing CO2 will lead to global warming. Right, appliances that do not automatically switch off when they are not being used should be banned. Suggest why scientists alone cannot make the decision to ban these appliances. Well, this is down to governments or down to people to make this policy up. So scientists alone cannot make this decision. It would be down to the people. So it's a decision that is not a science decision to make. It is down to governments or people to make their own choices. Okay, the diagram shows a simple tire of a car rear window heater. The 6 heating elements are exactly the same, so it's a single type, not tire, sorry. Now this has no branches, so clearly, because it has no branches, it must be a series circuit. So we need to use the rules for a series circuit. It says each heating element has 5 ohms of resistance, and there are 6 heating elements. So we know that our rules for a series circuit are that we simply add the resistors together. So if we have 6 resistors and each one is a resistance of 5 ohms, then 6 times 5 gives us a resistance of 30 ohms. Why is the current passing through each element the same? Well, because it is a series circuit, it just follows one path. So the current is only following one path. So the elements are in series. There is no alternative paths for the flow of charge. Now remember, the flow of charge is current. What is the total current passing through the whole circuit? Well, we know if it's 0.4 amps at any point, it is the same everywhere, so it must be 0.4 amps. How is the 12 volt potential difference of the car battery shared between the 6 heating elements? Now remember, for voltage, if you have a 12 volt battery, then all 6 will get the same, so they would all get 2 volts each, so it would be shared equally. They would all have 2 volts. Right, the diagram shows a hairdryer. Diagram 2 shows how the hairdryers and heaters and fan of the hairdryers are connected to a 3-pin plug. The hairdryer does not have an earth wire. What colour is the insulation around the wire connected to the live? That would be brown. Now remember, the other wires would be blue and green and yellow. Now green and yellow is the earth wire and blue is the neutral, brown is the live wire. Why does the hairdryer not need an earth wire? The reason is it's totally wrapped in plastic and we call it double insulation. So it has double insulation and that is the plastic outer coating. So there's no way of you touching any wires on the inside, so you don't need an earth wire. All the switches are shown in the off position. Which switch or switches have to be on to make only the fan work? Well, for only the fan to work, clearly this is the only switch because that completes the circuit. So that one must be S1. For heater 2 to work, then you're going to have S1 on, and you're also going to need that one to work as well. So that will be S1 and S3. Okay, the next question says the heaters can only be switched on when the fan is also switched on. Explain why. Well, the reason is the fan is part of S1. So if S1 is on, then the fan is on. So as soon as you put S1 on, the fan must come on. For any of the other 2 switches to be on, if you turn on S3 or S2, the fan must already be on. If you just turned on S2, none of them would work. If you just turned on S3, none of them would work because they would need S1 to be on for them all to work. So S1 needs to be on for the fan to work. If S2 or S3 are switched on with S1, the fan must also be on. Now remember, this is in parallel, so fan is in parallel to heaters. So because it's in parallel, it must be on because this is a part of a parallel circuit, and we know for this part of the parallel circuit to be on, S1 must be on, and therefore it works. Right, the different table shows the current drawn from a 230 volt supply. Calculate the maximum power of the hairdryer, and we're given something in amps. So the largest amount of amps is 6.5. So we know that power is equal to voltage times current. The voltage is 230 and the current is 6.5. So if we multiply the two together, we get 1,495 watts. Remember, this must be a capital letter, so power is measured in watts. Okay, question 7. What is the name of this compound? And remember, this is the typical graph that you will get for a filament bulb, and what it's showing is at certain levels the graph is directly proportional. This is a straight line, although I haven't shown it very clearly, and then it starts to curve. It is directly proportional when V equals IR. So what that's saying is when you increase voltage, the current increases by the same amount if this is kept constant. And the only way you can keep this constant is if the temperature is constant. As soon as the resistance increases, this relationship no longer happens and it starts to curve. Here we just have it with the electrons traveling the opposite direction, and that's why you get a negative value for current flow. So this is because it is AC, and with an AC wave you get a positive value with the electrons going one way and a negative value with the electrons traveling in the opposite direction. Okay, so figure 2 shows a circuit containing a 6-volt battery. Two resistors X and Y are connected in parallel. So we've got these two in parallel with 3 amps going in. If 2 amps goes that way, then we know this way there has to be 1 amp of current. Now, because these are in parallel, we know that the start of every parallel branch must be 6 volts going into both and 0 volts coming out of both. So that's really important when you do a parallel circuit. Recognize that whatever the battery is producing as a potential difference, each branch must be getting the potential difference of the whole of the battery. So what is the potential difference across X? Well, it must be 6 volts. Calculate the resistance of X. Well, we know if going through X there is a voltage of 6 volts. If V is equal to IR, then R is equal to V divided by I. So therefore 6 volts going in. There's a current of 2 amps going through that, so that must equal 3 ohms. So the resistance is 3 ohms. What is the current in Y? Well, we just talked about this splitting. So 2 amps goes that way, 1 amp must go the other way. So that must be 1 amp. Calculate the resistance of Y. So this time R is equal to V, which is still 6, but the current is 1. 6 over 1 is 6 ohms. Right, when the temperature of the resistor increases, its resistance increases. What would happen to the potential difference across X and the current in X and the total current in the circuit? Right, so the first thing is what's going to happen to the potential difference. So the potential difference is going to stay the same because it's just going to be the maximum value of the cell. What's going to happen to the current? Well, if you remember this relationship that V is equal to IR and therefore R is equal to V over I, if we increase the temperature and the resistance increases, if we increase R, because this is inversely proportional, then I must decrease. So therefore this one is the correct box. So if we increase the resistance, we decrease the current flow. And the last one, the total current in the circuit, well, that must also decrease as well due to this relationship. Now remember, resistance is inversely proportional to current. So increasing resistance decreases current, decreasing resistance would increase the current because of this relationship. This is directly proportional, this is inversely proportional. Right, for question 8, we've got a clear relationship where V is equal to IR because these are directly proportional. So it says, using figure 1, how can you tell that the temperature of each wire is constant? Well, that's because the graph is directly proportional. So the graph is directly proportional. So you get a straight line. Now you will only get a straight line when V is equal to IR. So we say that this obeys Ohm's law. Ohm's law is this relationship. It means that when you increase the voltage, you increase the current by the same amount because R is constant. And that gives you a directly proportional relationship. Which one of the wires, A, B or C, has the greater resistance? It must be C. Why is it C? Because for the same potential difference, if this potential difference, for example, was 10, at 10 volts you've got a current here which is low for C, higher for B, and much higher for A. So because the current for C is lower, the resistance must be higher. So which one of the has the greatest resistance? The answer is C. For the same potential difference, the current is lower. Okay, so in the next question, it says the table below shows the resistance of and other data about each of the 4 wires J, K, L and M. So we've got 3 materials made of copper and 1 made of constantan. The last column of the table should include the resistance. What is the unit of resistance? Well, that's in ohms. The resistance of a wire depends on many factors. Look at the table. Which 2 wires from J, K and L and M show the resistance of a wire? So we're going to look at ones where we're seeing the only thing they're changing is the length. So here they've changed the length and the diameter is 0.17, but on the other 2 the diameter has changed. So we can only focus on K and L, because in K and L they are both made of copper. They've changed the length, which is what we're looking to change. The diameter is the same, so they've kept the same diameter and they've kept the same material. So there are controls, and the one thing they've changed is the length. So the answer is K and L, because material and diameter is controlled, i.e. the same, and the length is what is changed, the independent variable. A student looked at the data in the table and wrote this conclusion. The resistance of a wire depends on the type of a metal from which the wire is made. The student could not be certain that a conclusion is true for all types of metal. What extra detail is needed, or what extra data? Well, you'd need to do it with more metals. So if you've only used 2, you cannot make that conclusion, so you would need to test with more metals. Okay, so in the last question, the resistance of a wire can be calculated using the readings from an ammeter. Complete figure 2 by drawing the voltmeter in the correct position in the circuit. So we know that the ammeter goes in series, like so. The voltmeter would have to go in parallel to the wire, like that. So it could go here or it could go here, as long as it is in parallel to this wire, because you are measuring the potential difference, the energy change across the wire. In a circuit diagram, a wire can be represented by a symbol for a resistor. Draw the circuit symbol for a resistor. It looks like that. Okay.